Hi, I'm Ryan Nickel, CTO at DSA Ocean, and today I'm going to show you how to carry on your aquaculture grid mooring system analysis from currents into a dynamic wave analysis. So where we left off, we had generated a bunch of steady cases of a fish farm system in a steady current. Those simulations have completed after some time. If we go straight into the results file and load one of these cases, just double click on the results.pdso, it'll open up in ProteusDS. It's always good to spot check these results. It can be tricky and easy to make a mistake in terms of file output or having an incorrect current speed or not turning on the waves when you get to the wave loading analysis. So it's always good to check and just do a visual check. And you don't have to do it on every single one of them, but just always good to check your work this way. You can also peek at the results as they're progressing through and see how things are going, and to save time as well. So here's our fish farm system in ProteusDS. Just make this a little bit bigger. And it's a little bit easier to see things with engineering view. So we'll switch to display type engineering view, and we'll plot some tensions here and show the legend. So, we're seeing a pretty uniform pretension across the whole system given the sag values that we'd specified in System Designer. Now, it's a steady current condition, so you can see that the current going from the left to the right. In this specific case, we're seeing deflections in the cages, and the bridle lines are looking right. And of course, this is what we would expect to have two of the main mooring lines picking up a lot of the tension, these ones a little bit less. And what we can do is plot those results too. And there's quite a lot of components in here. When you get to plotting, you can pick several things to plot at the same one. I'm pretty sure these are mooring line 18 and 19. Sometimes I just click on them to show their visibility. You can click on them, it's a little bit hard to do that sometimes. So right click and then go plot tensions versus time. And again, you can filter here by mooring line. We'll pick 18 and 19. So these should see pretty much the same values. End 1 is going to be the end connected to the grid. And here you can see in the tensions for both of those lines, it's converging, probably 60 seconds, maybe 80 seconds, and it's reaching just under 18 kilonewtons steady load in those. So that's not the maximum load, that's the steady load in the current condition. And now what we want to do is use this as the starting condition to apply ramping up wave condition. So there's more than one way to apply wave loads. A very standard process is to use a ramping up area wave, like a sinusoidal wave, and then a full wave amplitude to sort of get a maximum wave going through the whole system and see what the dynamic load is on top of that. And that's what we're going to show how to do in this tutorial. So everything's looking good. What we want to do is go back here, and we're going to use Case Explorer again. So we'll open up ProteusDS Case Explorer. Now, rather than going new, instead of that, what we do is we go import results, and we pick our old current cases file. And what it's going to do is automatically pick the final state from all our current cases and use that as the starting state for this case. So right away, I'm just going to save this as a new file, wave cases. Just go save, and you can see it's creating a set of folders for us, but we need to make some changes to these, right? So we're not done yet. And again, my preference is for this kind of process in aquaculture grid systems here is to switch to the fish farm view, and you can see here we've got all the currents already configured for this, which is great. Okay, and now what we want to do is, first what I want to do is go through and specify all the wave height data that I've got. Now, this is not the real wave height data for this system, it's just representative for the purposes of the tutorial here. Of course, you'll need to have this data for your site. And I'm just picking a few values here, with the biggest, being 1 meter significant wave height, and then we've got the associated peak periods for each direction here. Just putting in the data. Okay. Now, we'll need to make a few other changes here as well. So I'm going to go Control A just to select all cases. Want to make sure we actually turn on the wave. So we have the data in here, but we have to select what kind of waves we want. So we'll do airy wave, and airy just is another name for a sinusoidal wave. And the wave height standard here, if we pick NS9415, what that does is apply a scaling factor of 1.9 to the significant wave height. So this is just a statistically derived parameter that sort of says, well, you're likely to see in these sea states individual maximum wave that's got a factor of 1.9 on the significant wave height. And that means also it's going to have different values for each case because we've got different significant wave heights. So we want to leave these all just as mixed here. The other thing we need to do is we need to change the sim duration and output interval. We probably need something more like 0.1 just to get a nice resolution of all of the dynamic loads. But you may need to get some experience and comfort level with that. Now, we don't need to run these for 300 seconds each, and this is where the simulation time button can help us. So we click on that, and the simulation time can be a function of the wave period for each case. That's what that's telling us here, and we just basically want to run it for 2 wave periods for each case. We also do want to have wave ramping, and that's going to be the first wave period. And so what that's going to do is ramp up the airy wave in the first half of the simulation during 1 wave period, and then 1 full wave period, and we want to do that with all cases. So you see that sim duration is mixed now. If we click on this case, just for example, we have 6-second peak period. So we've got a wave ramp duration of 6 seconds and sim duration of 12 seconds. And I think we've got everything all set up. Now what we do is just save this, and never a bad thing to check. Just take a quick look. Now you can open the simulation toolbox files if you like, and just verify what you're seeing in there. There's the current profile and the associated depths and the heading. That's what we want. And we've got a wave period of 5. Now this is going to be 1.9 times, the 0.25 significant wave height, which is good. And everything's looking good. We've got a simulation output rate of 0.1 and just 10 seconds of simulation, because that's 2 times the wave period. I think we're looking good. So as before, we'll use ProteusDS Queuing Manager to run all these simulations. Again, you may wish to zip this up and copy it onto another computer, and I'll just start them running here. And this should take much less time than the settling simulations, because the simulations are pretty short. But what we'll do is we'll let these run, and the next video we are going to take a look at the results and then post-process them using the Fish Farm Report tool.